In this video, we're going to go through a summary, basically, of all the previous videos that I've made regarding transformations. And then we're going to do an example where we have to do a lot of transformations all together, and how do we handle multiple transformations. Okay, so first, this page here I have written out a summary. First thing, when you're doing multiple transformations especially, you should definitely always start by getting your equation into this format, or your function into this format, where you have some constant times whatever the function is, and then you can pull out some other constant, and then you have x plus c, and then you might have some additional, so plus d on the end. Okay. So here, if you have it in this format, then you have A is a vertical stretch or compression. If A is not a fraction, then it's a stretch. If A is a fraction, then it's compression. If A is negative, then you're going to reflect over the x-axis. Okay, and this is, if this xy came from the function f of x, this is the transformation. You do x and then a times y. Okay, and then for B is the horizontal stretch or compression. If B is not a fraction, it's a compression. If B is a fraction, then it's a stretch. Okay, so notice that these two kind of did a switch. And then if B is negative, then you reflect over the y-axis. And this is how you get, from the xy to the transformation. You multiply all the x's by 1 over b. C is the horizontal shift. If C is negative, it's a shift right. If C is positive, it's a shift left. This is the way you do the shift. You do the x value, because it's horizontal, right? So the x value minus whatever C is. Okay. D is the vertical shift. So the vertical shift would be, if D is positive, you shift up. If D is negative, you shift down. And, you would do the shift on y, so it would be y plus d. Okay, so in the next example, I'm going to talk about how to do multiple transformations in a sequence, and really the sequence follows this as I've written here, A, B, C, D. First you do the transformation for A, then you do it for B, C, and then you do it for D. Okay, so now let's do an example where we need to do multiple transformations in sequence. So first thing I want to do is make this look like in the format that I had the previous, in the previous slide. So in the previous slide I had A times f of B, x plus c, and then plus d. Okay, so I want to identify which each of those things are here. So if I have, what is g of x? Well, first off, what is f of x in this one? We need to identify that. You see here, f of x is x squared. This, being able to recognize, so basically this is f of x is x squared. The more practice problems you do, the quicker it will become to recognize what f of x is, but clearly that's going to be the most important thing that you need to be able to recognize here. So, a is going to be 1/3, right? And then, so when you see f, you'll be plugging in, for this x squared here. Okay, so I'm going to write that 1/3, and then instead of writing x squared, I'm going to write f. What am I plugging in for f? I'm plugging in this 4 minus 2x. And then I have this plus 3 on the outside. Okay, now I'm trying to get it into this format. One last thing I want to do to get it into the format is I want to get x by itself, basically, so I'm going to pull out a -2. So then I'll have -2 plus x. Okay, I'm just going to rearrange this so that it's in exactly the same format. So it's going to be x minus 2. Okay, so you see -2 plus x, same thing as x minus 2. So now we see, oh, okay, so A equals 1/3. B equals -2, C also equals -2, and D equals 3. Okay, so let's think about what this means with regards to, the transformations. So starting with A is the vertical stretch or compression, right? And remember, if A was less than 0, then it was a vertical compression, or less than 1. Well, if it was a fraction. If A was a fraction, it was a vertical compression. So this is a vertical, so we can say there is a vertical compression by factor of 1/3. Okay? And then next we have B. B is a horizontal stretch or compression based off of if it's a fraction. If it's not a fraction, then it's a compression. So this is a horizontal horizontal compression by factor, let's see, what is B? 2. Okay. Then C is a horizontal shift. If C is negative, it's a shift to the right. So we can just, instead of saying horizontal shift to the right, that's kind of repetitive, so you can just say shift to the right, shift right by 2. Okay. Then lastly, D, which is a shift vertically, so up or down, and it'll be up because D is positive, so shift up 3. Okay, so now I'm ready to go ahead and do this graph. So if I were to take 1, 1, here's 1, 2, 3, 4. Okay, so there's are points there, and then here at 2, -2, so -2, it's 4, 2, it's 4. So my parabola looks like this. So that's f of x. Okay, so now we need to do the transformation to find the graph of g of x. So the way I do this usually is I just go ahead, let's just use a few points. So I'll start with, the point maybe 1, 1. And then maybe we can also do the point 0, 0. See how it's affected by each of these transformations. Okay, so 1, 1, by vertical compression of 1/3, this will then become 1, 1/3, right? You multiply the y by whatever you're compressing it by. So 1 times 1/3 is 1/3. And then 0 times 0, or 0 times 1/3 is 0, so this one won't change. If I were to maybe also do the point -1, 1, this will go to 1, or -1, 1/3 as well. Okay. So now moving with these new points, okay, so these now are the new points. Now I go on to the next transformation. So this is what it means to go in sequence. You should follow this order. Do A, then B, C, and then D. Okay, so now I'm going to take 1 and 1/3. So, oops, 1 and 1/3, and do the horizontal compression on it, which means that I'm going to be multiplying the x term by 1/2, right? For horizontal compressions, you do 1/b. So this will go to 1/2. Oh, I just noticed that we forgot one of our transformations here. There should have been a flip, right? Because b is negative. So there should have been a flip over, remember when b is negative, you reflect over the y-axis. So flip over y-axis. Okay? Now these two, flip over the y-axis and the horizontal compression by 2 can be done at the same time. So if I just multiply it by negative, so 1/b as opposed to 1 over the absolute value of b. So if I just keep the sign, basically. Okay, so 1/b would be -1/2. And then I have 1/3 stays the same. Then my next point, 0, 0, this just stays the same. If I multiply it by 1/2, the x component by 1/2, nothing happens. And then last one, if I want to do the negative 1 1/3. So the negative 1 is going to go to, so negative 1 times negative 1/2. So that's going to be positive 1/2 and 1/3. Okay? So actually, you know, for this particular graph, the flip over the y-axis didn't do anything because, you know, this is a symmetric graph. And so when you flip it over the y-axis, nothing happens. If you flip it over the x-axis, well, that's more meaningful. But flip over the y-axis is not as meaningful. Not meaningful at all, actually, in this graph. Okay, now let's do the shift by 2, shift to the right by 2. So shift by the right, that means we're going to add 2 to the x term. So negative 1/2, 1/3. So when you shift that right and you add 2, so negative 1/2 plus 2 is 3/2. 1/3, okay? 0, 0. Now, when I shift that, that's going to turn into 2, 0, okay? And then 1/2, 1/3, that's going to turn into 5/2 and 1/3. Okay, last thing, shift up by 3, so that's going to be plus 3 to the y term. And so starting with 3/2, 1/3. If I add 3 to that, that's going to be 3/2. Let's see, 10/3. Okay, and then 2, 0 is going to go to 2, 3. And then lastly, 5/2, 1/3 is going to be 5/2, 10/3. Okay, so now I can graph all this. These last points are the ones that I'm going to graph at the end of all of my transformations. These are the points I have. So let's go ahead and graph these in red. So first starting with the 0, 0, that's the easiest one. So that's going to be 2, 3. So x is 2, y is 3. 1, 2, 3. So it's here. 1, 2, 1, 2, 3. Okay? Then the next point, let's go ahead and do this 3/2, 10/3. So 3/2, that's, you know, 1 1/2 basically. So that's somewhere around right here. And then 10/3 is a little bit more than 3. It's a third more than 3, right? So it's like somewhere, it's kind of like right there. So here's 4, so it's a little before 4, okay? And then 5/2, so that's basically 4 1/2, right? It's right there. I mean, not 4 1/2, 2 1/2, which is right here. And then 10/3 again, okay? So this, you know, this is basically the way my graph is going to look. And so that's g of x.